Hello, welcome to Physics 310. This is second video of chapter 2. We are going to do some example problems based on what you have learned in first part of this chapter 2 video. So we are going to do example 2.1, and it says that a car passes telephone pole number 1 located 20 meters down the street from the corner lamp post at a time t1 is equal to 8 seconds. It then passes telephone pole number 2 located 80 meters from the lamp post at a time of t2 is equal to 16 seconds. What was the average velocity of the car between the positions 1 and 2? So let's see again what it says. A car passes telephone pole number 1 located 20 meters down the street. So suppose this is the street and here is your starting point. Okay, origin, and 20 meters, and suppose this is the street, and 20 meters from here there is a telephone pole. Okay, this is 20 meters. And this is pole number 1, pole 1, and the car is passing here. A car is passing here, pole number 1, at time t1. Here the time t1 is how much? 8.00 seconds. So at this position the time is 8.00 seconds. It then passes telephone pole number 2. So there is a pole number 2 somewhere. This is pole number 2, and this pole is 80 meters from this origin. This origin is a lamp post. So here is a light lamp post, the starting point, and from here this is 80 meters, and the car comes here at pole number 2 at time t2 is equal to, at time t2 is equal to how much? 16 seconds. 16.0 seconds. So what was the average velocity? So how do we get average velocity? What is the formula for average velocity? V average V suffix average is delta x, change in position, over change in time. Suppose this is your x-axis. So in other words, it is x2 If this position is x1 is 20 meter, this position is x2 is x2 is 80 meter. So x2 minus x1 over t2 minus t1. So this gives you V average is equal to, this is 80.0, 80.0 meter, and this is 20.0. So 80.0 meter minus 20.0 meter over 16.0 second minus 8.00 second. So what you get equal to 60 meter over 8 point. This is 60.0 meter over 8.00 second. The answer comes 7.5 meter per second. So V average is 7.5 meter per second. Let's do another example. Example 2.2. A car passes telephone pole number 1 at t is equal to 0 on a watch. It passes the second pole 60 meter down the block 8.00 second later. What is the car's average velocity? Okay. So now the reference is shifted. If you see the previous problem, the reference was the lamp, and from there the first pole was 20 meter away. Now here it says that pole number 1, and when car is passing here, in this example, the time is 0 second. You start counting the time. Okay, and when the car reaches pole number 2, pole 2, this pole 2 is 60 meter from this pole. Okay, this is 60 meter. So you have x1 0 meter, and here x2 is 60.0 meter. Okay, so again V average, it becomes delta x over delta t. This becomes x2 minus x1 over t2 minus t1. This is t2. t2 is 8.00 second, and this is t1. t1 is 0 second. So this becomes 60.0 minus 0 over 8.00 minus 0 is equal to 60 by 8, and 60 by 8 is again, this is 60 by 8, and this is equal to 7.5 meter per second. If you see the example 2.1, which we did earlier, the reference position has been changed. Alright, they are same problems but with different reference position. Alright, in this one the starting position was the lamp post, and from here we are measuring the things. Alright, in this example the starting position is the first pole. Alright, from here we are measuring all the things. Alright, so time is 0 here. Let's do example 2.3. There is a glider. In this example, a glider goes from a position of 20.4 centimeter at a time of t is equal to 10/30 second to a position of 103 centimeter, okay, at time t is equal to 50/30 second. Find the average velocity of the glider during this interval. So there is some glider, and its position so you have reference somewhere, okay, your starting reference point is here somewhere. This position x1 is 20.4 centimeter at time t1 is equal to 10/30 second. Okay, and you can change this in meter. You know how to convert from centimeter to meter. Like x1 is 20.4 centimeter. You need to put centimeter in the denominator and meter in the numerator. 1 meter stands for 100 centimeter. Centimeter and centimeter will cancel out. That will give you 0.204 meter. And then it glides and goes to another position. Okay, another position at x2 is 103 centimeter at time, another time, though it is written t, we can say it is t2, another time 50/30 second. Okay, so x2 will be how much? x2, if you convert in meter by the same way, 103 centimeter, and basically you divide by 100, that will give you 1.03 meter. Okay, so what is V average? V average is delta x over delta t Okay, and final position minus initial position divided by final time minus initial time, and this gives you V average is 1.03 meter minus 0.204 meter over 10 by 30 second minus 50 by 30 second. So what you get on the top, this equal to, if you take a difference of 1.03 and 0.204, how much you get? You will get 0.826 meter over, I'm sorry, this has to be opposite way. This has to be final time 50 by 30 minus 10 by 30. This has to be opposite. T2 minus T1. It means that this is 50 by 30. So let's put these values. V average equal to x2 is 1.03 meter minus 0.204 meter over T2 is 50 over 30 second minus T1 is 10 over 30. So this is 50 over 30 minus 10 over 30. The difference is 0.826 meter, and this difference 50 over 30 minus 10 over 30, you will get 40 over 30 second. Alright, so V average is equal to 0.826 times, I just flip it, alright, 30 over 40 meter per second. Alright, this gives you how much? This gives you 0.62 meter per second approximately. This gives you 0.62 meter per second approximately. Let's do another example. Example 2.4. A glider's velocity on a tilted air track increases from 3.83 centimeter per second at time 10/30th of second, time to a glider's velocity on a tilted air track increases from 3.83 centimeter per second at the time t is equal to 10 over 30 second to 42.3 centimeter per second at a time of t is equal to 70 over 30 second. What is the acceleration of the glider? This is very simple. Acceleration A is delta V over delta T, is V final minus V initial over T final minus T initial. Okay, in fact, So what will happen here? So what is initial velocity? V initial is how much? 3.83 centimeter per second. Okay. Can we convert to meter per second? What we need to do? So I need to change 3.83 centimeter per second. I need to change centimeter to meter. So I will put meter on the top and centimeter on the denominator. 1 meter stands for 100 centimeter. Centimeter and centimeter will cancel out. This will be 0.0383 meter per second. Okay. This is V initial. How about V final? 42.3 centimeter per second. What I need to do this one? 42.3 centimeter over second. I need to cancel out centimeters, so I'll put centimeter in the denominator and meter on the top. 1 meter stands for 100 centimeter. This cancels out and you get equal to 0.423 meter per second. V final. Okay. So let's put these values. Zero 0.423 meter per second minus 0.0383 meter per second over T final. T final is this one. This is T final and this is T initial. So 70 over 30 second minus 10 over 30 second. Okay. So A becomes, if you take the difference, it will give you 0.385 meter per second over, what is this here, 60 over 30 second. So 0.385 meter per second over 2 seconds. Alright. So what happens here? If you solve it, A will give you 0.192 meter per second over second. This will become meter per second square. Alright, this is meter per second square. Okay, second is written as S for second. Okay, let's do another example. Example 2.5. A car passes a green traffic light while moving at a velocity of 6 meters per second. It then accelerates at 0.300 meter per second square for 15.0 second. What is the car's velocity at 15.0 second? So there is a car, okay, and there is a traffic light here. Okay, this is a traffic light, and this is green, so it is going through this, passing this with a velocity of 6.00 meter per second. So here the velocity, you can say that this is your initial velocity, V initial, alright, is equal to 6.00 meter per second. Okay, now here from this point onward it accelerates. Somebody is accelerating, so when you accelerate, what happens? The velocity goes up and up and up. Okay, so somebody gives the acceleration. A is how much? 0.300 meter per second square. For how long? For a time t, for a time t is equal to 15.0 second. Okay, 15.0 second. So after 15.0 second, what is the car's velocity? Okay, so suppose the car comes somewhere here. Okay, what is the velocity of the car? That is V final we are looking for. So we have V initial is 6.00 meter per second. A is equal to 0.300 meter per second square. T is 15.0 second. Okay, and then we are looking for V final. What is V final? You remember earlier I described the kinematic equations of motion. V final is equal to V initial plus AT. V final square is equal to V initial square plus 2A delta x, and delta x is equal to V initial t plus 1/2 AT square. One of these three equations is going to give you V final. Now you need to decide which one is the best one to solve this problem. So this equation has V final, this equation has V final. I am looking for V final. Okay, so, and this equation don't have V final, so we will not use this one right now. We have acceleration and we have time. We don't have delta x, so we cannot use this equation also. The only option is left with this equation. So using V final is equal to V initial plus AT, you get V final is equal to 6.00 meter per second plus 0.300 meter per second square times times how much second times 15.0 second. Okay, and see what happens. V final is equal to 6.00 meter per second plus 4.5 point, how much is coming this one? This is coming 4.50 meter per second if you multiply this number. So V final is equal to 10.5 meter per second. Okay, that was easy example. Let's do another example 2.6. What it says that a car initially traveling with 30.0 km per hour. So V initial is 30.0 km per hour. You have to convert in meter per second. And how to do that? Let's get rid of kilometer. Let's put kilometer in the bottom and meter on the top. 1 kilometer means kilo means 1000. 1000 meter. 1 kilometer means 1000 meter. And let's put hour on the top so that they can cancel, and the second on the bottom. 1 hour has 60 minutes and each minute has 60 seconds. So there are 60 times 60 seconds in an hour. That comes 3600 seconds in an hour. And if you solve this will give you approximately 8.33 meter per second. Okay. So a car initially traveling at 30.0 kilometer. A car initially traveling at 30.0 km per hour accelerates at the constant rate of 1.50 meter per second square. So acceleration is given how much? 1.50 meter per second square. How far the car will travel in 15.0 seconds? How far? What does it mean, how far? How far means we are looking for delta x. Okay, change in position. How far? And the time is given 15.0 second. Okay, 15.0 second. So again we have three equations. V final is equal to V initial plus AT. V final square is equal to V initial square plus 2a delta x. Delta x is equal to V initial t plus 1/2 at square. One of these three will be useful to solve this problem. Now we are looking for delta x. So this equation don't have delta x, so we are not going to use this one. Okay. And this equation has delta x. But to find delta x we need V initial, we do have it. We need A, we do have it. We need V final, we don't have V final. So again we cannot use this equation. Let's see the third one. Delta x we need. We have V initial, we have A, we have time. Okay, so we can apply the third one. Using delta x is equal to V initial t plus 1/2 at square. Delta x is equal to 8.33 meter per second times 15 second. Let's write here on the bottom. So we have delta x is equal to 8.33 meter per second into 15 second plus 1/2 1.5 meter per second square into 15 second whole square. 15 second square. So delta x is equal to, what happens here? If you solve this, the first one is coming about 125 meter, and the second one 15 square is 225, and 225 times 1.5 and divided by 2, this will give you 169 meter approximately. So delta x is equal to 294 meter. Let's do one more example where we can use the formula V final square is equal to V initial square plus 2a delta x. Okay. Suppose example. Suppose there is a car. A car has initial velocity 10 meter per second, accelerates with constant rate of 1.5 meter per second square for 100 meter. what would be velocity of the car? What would be the velocity of the car? Okay. After moving 100 meters, right? So V initial is 10 meters per second. V final we don't know. We know A is 1.5 meters per second square. We know delta x is 100 meters. So we can use this equation to find V final. V final square is equal to V initial square plus 2A delta x. V final square is equal to 10 square plus 2 times 1.5 times 100. V final square is equal to 100 plus 300, 400, square root of 400. Alright, plus minus. V final is plus minus square root of 400. Meter per second. Alright, you can put all the units over different places, but when you compute it, the final unit will come meter per second. Alright, so what will happen here? This is plus minus 20 meters per second. Alright, there are two possibilities, plus and minus. Now you have to decide which one is the correct one. If car is traveling in plus x direction, alright, so we have to take the positive value. V final is equal to plus 20 meters per second.